Welcome to Module 3 in Navigating Computer Systems. In this module, we will cover file systems and security. The term file system is an overloaded term, so we're going to be looking at two different views of what a file system is. First is the Linux file system. The Linux file system represents all the files, directories, and devices of your Linux system in a tree-based hierarchy. Then the second view is the disk file system. So this is going to be the software layer that controls how files are organized and stored on a storage device such as a hard drive, a USB drive, a floppy disk, etc. As usual, in this module, you're going to have an assigned reading, an activity, and a quiz. For the assigned reading, you're expected to read Chapter 4 of the Linux User Guide that's provided to you. And we also want you to read Chapter 2, the file system, in the Unix Programming Environment textbook. Make sure to read Chapter 4 especially carefully in the Linux User Guide because it covers many of the commands that you'll be using in the activities. For the activity, you're going to have 4 different scenarios that you're going to walk through to explore different aspects of the file system. Scenario 1 is going to be called Scavenger Hunt Linux Style, and in this scenario, you're going to learn about learn about files, directories, permissions, and just how the files and directories are structured in a tree. Scenario 2 is called Linux File System Lockdown. This is going to walk you through file directory permissions and groups. Scenario 3, putting the squeeze on files. We'll talk about how you can pack up files and compress them to shrink the size because this is a common thing that developers want to do. Room to grow is scenario 4. And in scenario 4, you're going to be adding more disk space to your machine. So let's say you have a large data set, you run out of space on your computer because you're analyzing all this data. You can attach a virtual hard disk to your virtual machine. You're going to partition and create a disk file system, and then you're going to mount it onto your existing machine. Super useful skill. So let's go through each scenario in detail. Scenario 1, some of the commands that you're going to encounter are the pwd command, which stands for present working directory. This will tell you which folder you're currently in, which is a great tool when you're exploring the file system. The which command will tell you where a command is located on your machine. So if you want to know where you can find the ls command, you can say which ls and it will tell you. So if I go over here into my console, I can say which ls. It's in /user/bin. So /user/bin is going to be where most of your commands are located. So if I say which cd, I can see it's in /user/bin and it's located at cd. If I say which eclipse, which is the command to run Eclipse, I can see that it's actually an alias, but the command is located in ~eclipse/java-2020-03 eclipse. So that's the which command that you'll see. The du command will tell you how much disk usage, so it stands for disk usage. It's going to tell you how much space is being used by various files on your machine. ls-l will give you more details about a file. And along with ls-l, you can see the different permissions that a file has. So if I go back over to my virtual machine real quick, just to give you an idea what that ls-l does, if I type ls in my home directory, I have all these folders. If I type ls-l, stands for long listing, I can see more details about all of these different folders. So I can see that cs-hu153 was created on June 1st. Right here, I can see Marissa Schmidt. I am the owner of this file or directory. My second name here, Marissa Schmidt, again, this is going to be the group. So we'll talk more about that in the next scenario, but this is a group. I am in the Marissa Schmidt group. I own that directory. And over here is an octal representation of the permissions on this file. So I highly recommend reading the Chapter 4 in the Linux guide that we gave you because it will go into detail into what all these parameters mean. But if I look specifically at cs-hu153, I can see the D stands for a directory. This is a directory. RWX stands for read, write, execute on my user. So Marissa Schmidt can read, write, and execute this folder. The second three letters represent the group permissions. So read, write, and execute for the group. And then the third set is going to be other people. So everybody else on the system just has read and execute access. If there's a dash, that means they do not have the rights to do that operation. So in order to secure your system, you have to understand how that's working. Scenario 2 will expand upon this idea. You will explore how to view all the files in a tree-like structure. You will look at groups and adding new groups, adding people to groups, and you will also look at how to change the permissions on the files using the change mod command. So the commands that you'll use are wget, which is somewhat related. You're just using it as a tool to get a large file onto your machine. wget is webget. It'll grab a file from the internet. tar, again, is just a tool that you need in order to do the other exercises. You'll explore it in scenario 3 further, but tar will basically unzip. If you've ever used a zip command on Windows, it'll unzip a large file. Tree is a command that you may have to install. So that's the one I'm going to explore over here in a second. So let's go look at the tree command on my virtual machine. If I type tree, it'll tell me that the command is not found. So what do we use? You did this in Module 1. How do we install a command on our machine? I can use yum. So if I do sudo yum install tree, get my password correct, then it will go and find it and hopefully install this tree command that we mentioned in the write-up. Perfect. So now that I have it installed, if I type tree from my directory, I can see that all of my files are organized in a tree-like structure. So if I scroll to the top, in my home folder, I have a CSHU153 folder. Within that folder, there's a Module 1 folder, Module 2, Module 3, Module 4, Module 5. Within the Module 3 folder, I have a file called master.zip. So I can see this structure for all of the files that are in my home directory. Okay. After you have a chance to explore the tree command, you'll use the group add and change group commands to manage groups. You're going to first create a developers group on your computer, and you're going to change ownership of given files to that developers group so that the developers group has access to all those files. Then you'll change individual file permissions for that group as well using the change mod command. So let's go explore groups a little bit. You'll do some reading on it, but just to show you live here, if I type the groups command on my fresh install of Linux, I can see that the groups that I belong to are Marissa Schmidt and Wheel. So every user is going to belong to a group that's tied to their own username. The Wheel group is actually the group that will manage access or control of the sudo command. So the sudo command you used in Module 1 when you set up your virtual machine is used to run commands as an administrator or as the super user. So anybody who is in that Wheel group has access to run sudo commands. You're going to use the group add command to create your new developers group, and then you'll change ownership of files to the developers group using the change group command. After you change ownership using the change group command, you'll change file permissions within that folder using the change mod command. So change mod is a way that you can set the different read, write, and execute permissions on a file. In scenario 3, putting the squeeze on files, you're going to explore how to package files and compress them so that you can potentially save space on your machine or send files to other developers. So the commands that you'll look at are unzip and zip. So you should be familiar with zip command from like a GUI graphical interface. You just right click and say unzip, or you can zip up a bunch of files and send it over to somebody in an email. So you'll explore how to use those from the command line. And then another version of zip called tar is going to be explored as well. So tar is very similar to zip. They're just different compression algorithms, just different algorithms for bundling up files. And you're going to actually compare the sizes of the compressed files using zip and tar to see which one compresses better or makes it smaller, or which one's larger, using the DU command, that disk usage command. In the final scenario, scenario 4, called room to grow, you're going to add an additional storage drive to your virtual machine. To do so, you're going to use several commands to interact with the file system. The df command will examine available free space. The lsblk, which stands for list block or list block devices, will list all storage, also known as block devices, connected to your system and the partitions on those devices. fdisk is actually an interactive tool that's used to create partitions on existing block devices. Partitions are used to split like a hard drive, for example, into multiple sections so that you can isolate the storage between multiple sections of that hard drive. So if one partition runs out of space, it doesn't affect the functionality of the other partition. Makefs is make file system. This creates a disk file system on an existing partition. So you're going to be formatting it to store files, essentially, if you make it a disk file system. So the types of file system we're going to use in this module are ext4, but there's ext3, ext2, xfs. There's a lot of different types of storage device systems that are all optimized for different purposes. You are going to use the mount command to attach a device, or attach the device that you just created to the Linux file system directory hierarchy. So once you create the hard drive, you format it to be ext4, you're going to mount it onto your existing machine so that you can browse to it just like you change into all of your other file system, or all of your other directories on the file system that already exists, so that it's seamless. Just keep in mind, mounting is not permanent though, so you're also going to be editing a file called fstab, which stands for file system table. So that way, if you reboot your machine, it remembers where the device is and you can still navigate to your files that are on that external storage device. Another command that you'll look at is umount, which is unmounting the file system or the device once you mount it. So if you change your mind, you no longer want it to be mounted, you can use umount. My biggest piece of advice to you for this module is to take your time and read the Linux guide that we link in the activity very carefully. Read carefully. So if I'm going back to the Linux guide over here, I have it open just to show you the sections that you should focus on. It says in the guide to look at section 4.7 in particular. So section 4.7, called Devices and Partitions, gives you an introduction. 4.7.2 talks about creating and working with file systems. 4.73 through 4.74, 5, 6, and 7 go through those commands that I just mentioned in more detail. And they also reference an image that's on page 51. So this image is going to be very important because it takes you through the whole process of creating your device and the partition and formatting it for ext4 file system, mounting it. All of the steps are in here. So you just need to read this carefully. You can follow the commands. They're also written in the guide. So make sure to look at the guide and this. They're kind of go hand in hand. But make sure to follow these directions carefully, especially when you're running the fdisk command, the interactive partition creator, I guess I can call it. Make sure that you're using the correct options. So N and then P. So just be very mindful to make sure that you catch all of them in here. And then finally, to add a hard disk or hard drive to your virtual machine, it says in the guide that this was given to you in module 1, but just to make it a little bit easier for you, I'll show you that process right now. On my virtual machine, I go to the settings for my VM. So I'm going to click right up here. However you get to the settings for your VMware or whatever you're using. In VMware on a Mac, it's called Add Device up here in the top right. So somewhere in your VM, there'll be a setting and there's somewhere where you can add a device, wherever that may be in your particular version. So if I click on Add Device, I can create a new hard disk. This is the option I want to create. If I click on it, it's going to tell me the device cannot be added until the virtual machine is shut down. So I don't want to show that to you right now because it takes a while to shut down and restart, but you have to physically shut down your virtual machine. So virtual machine, shut down, and then add the disk and then restart it. But after your machine is shut down, you'll click add, and then you can select and modify so that it's 8 gigabytes large. We want to allocate 8 gigabytes of space on that hard drive. Once you add the hard disk, if you run the df command, like I showed here, I already had run it after I added mine, df-h, you should see, maybe not on mine. Oh, right, I haven't mounted it or anything yet. So if I do lsblk, because it's a block device, it will show up in the list here. So you should be able to run lsblk after you add the hard disk, and SDB will show up. And it's 8 gigabytes. So if yours is not, SDB is not showing up, look for one that's 8 gigabytes in size. That's probably the one that you added. Okay, so when you're done with the scenarios, make sure to take the quiz. Just a quick reminder here, you can take the quiz twice. Just don't forget to take it. And that is all. Enjoy the module. Reach out on Piazza or during office hours if you have questions.